Well, welcome back to our course on system engineering. In this lecture, we're going to be talking about test and evaluation. And just to give you context where we are, we've had the three major sections that trace the life cycle. We have the introduction, all the foundations. We talked about the concept development, and this is going to be the last of the lectures that's devoted to the engineering development process. Then we'll get into the post-development stage and also just give some additional context for the whole system domain. So let's go ahead and get into the details here. And so let's first give some perspective on testing and evaluating the total system. Testing is often combined with the integration phase as the system is being developed and is often executed to ensure that the integration efforts were done correctly. The success of the evaluation effort is also highly dependent on the advanced planning and preparation for this effort that was accomplished during the previous phases. A detailed test and evaluation master plan, TEMP, is required to be formulated by the end of the concept exploration and elaborated at each step thereafter. In practice, such planning usually remains quite general until well into the engineering design phase for several reasons. One, the specific test approach is dependent on just how the various system elements are physically implemented. Two, test planning is seldom allocated adequately prior to either staffing or funding in the early phases of system development. And three, simulating the system operational environment is almost always complicated and costly. So the purpose of what we're going to talk about in this lecture and the corresponding chapter is to describe the essential activities that are typically required in this phase, a number of the problems that are commonly encountered, and some of the approaches to help overcome the resulting obstacles. Additional topics will include human factors and system considerations while developing the testing approach to the system. Well, let's go ahead and look at the place of evaluation in the system lifecycle, and I'll describe this chart in a moment, but it was seen in another lecture and another chapter corresponding to that the general process of test and evaluation is an essential part of every phase of system development, serving as a validation step of the systems engineering method. Can be generally defined as embodying those activities necessary to reveal the attributes of a product and pair them with expectations in order to deduce the product's readiness for succeeding activities or processes. In the integration and evaluation phase, the process of test and evaluation becomes the central activity, terminating with the evaluation of the total system and the realistic replica of the intended operational environment. So in this figure, we're showing a schedule and top-level effort, which shows the overlap of the integration and evaluation phase with the engineering design phase. The differences in the primary objectives, activities, and technical participants of the integration and evaluation phase from those of the engineering design phase are summarized in what we'll talk about next. All right, well, let's get into system evaluation and the evaluation team. That's a figure we're showing, but before we get there, we'll talk about a few other things: program focus, program participants. And so for the program focus, the engineering design phase is focused on the testing of the individual system components and is typically carried out by a number of different engineering organizations, with system engineering and program management oversight being exercised by the system testing specialist. On the other hand, the evaluation phase is concerned with assembling and integrating these engineering components into a complete working system, creating a comprehensive system test environment and evaluating the system as a whole. For the program participants, the primary participating technical groups in the evaluation phase are system engineering, test engineering, and design engineering. The functions are pictured in the Venn diagram that we're showing now, which shows the activities that are primary ones for each technical group and those that are shared. System engineering is shown as having the prime responsibility for defining the test requirements and evaluating criteria. It shares the responsibility for test planning with test engineering and the definition of test methodology and data to be collected with the design engineering. Test engineering has responsibility for test conduct and data analysis. It usually provides a majority of the technical effort during this period. In many programs, design engineering has a prime responsibility for test equipment design. It is also responsible for components design changes to eliminate deficiencies uncovered in the test and evaluation process. We'll talk about management scrutiny and then get into design materialization status. But first, talking about management scrutiny, a large-scale system development program represents a major component, a major commitment of government and/or industrial funds and resources. When the development reaches the stage of system integration and testing, management scrutiny becomes intense, and real or apparent failures are viewed with alarm, and temptations to intervene become strong. It is especially important that the program management and system engineering leadership have full confidence of top management and authority to act at this time. Then we'll get into this materialization at the integration and evaluation, and refer to this figure. The status of system materialization in the integration and evaluation phase is shown here. The table highlights entity entries identifying the principal activities in this phase are seen to be in the upper right-hand corner, departing sharply from the downward progress of activities in the previous phases. So these items here are what we're focusing on. This corresponds to the fact that in the other phases, the activities referred to the stepwise materialization of individual components, building blocks, progressing through the states of visualization, functional definition, and physical definition to detailed design, fabrication, and testing. In contrast, the activities in the integration and evaluation phase refer to the stepwise materialization of the entire system as an operational entity, proceeding through the integration and test of physically complete components into subsystems and then into the total system. A very important feature of the materialization status is the characterization of interactions and interfaces. This process should have been completed in the previous phase, but cannot be fully validated until the whole system is assembled. The inevitable revelation of some incompatibilities must therefore be anticipated as the new system is integrated. Their prompt identification and resolution is a top priority of system engineering. Accomplishing the integration of interfaces and the interactions may not appear to be a major increase in the materialization of the system, but the reality is a necessary step to achieve a specified capability. Now, considering this table, so that the view of the activities and objectives of the integration and evaluation phase can be further amplified by expanding the activities pictured in the last column of the table we were showing on the last slide. This is demonstrated in the table that we're showing now, which the first column lists the system aggregation corresponding to the integration level as in the previous table. The second column indicates the nature of the environment in which the corresponding system element is evaluated. The third column lists the desired objectives of the activity. And the fourth column defines the nature of the activity, expanding the corresponding entities in the table on the last slide. The sequence of activities which proceed upward in the previous table starts with tested components and integrates these into subsystems, then into the total system. The process then evaluates the system first in a simulated environment and finally in a realistic version of the environment in which the system is intended to operate. Thus, as noted before, in the integration and evaluation phase, the process of materialization refers to the system as a whole and represents the synthesis of the total operational system from the previous physically materialized components. In terms of the system engineering method in evaluation, since the structure of the evaluation phase does not conform to the characteristics of the preceding phases, the application of the system engineering method is correspondingly different. In this phase, the requirements analysis or problem definition steps correspond to test planning, the preparation of a comprehensive plan of how the integration and evaluation tests are to be carried out. Since the functional design of the system and its components have been completed in previous phases, the functional definition step in this phase relates to the test equipment and facilities, which should be defined as part of the test preparation. The physical definition or synthesis step corresponds to subsystem and system testing facilities and events. The components have been implemented in previous phases. The design validation steps corresponds to system test and evaluation. The organization of the principal sections that are covered in this lecture and the related chapter will follow the order of the above sequence. However, it is convenient to combine test planning and test equipment definitions into a single section on test planning and preparation and divide system tests and evaluation into two sections.